example. Here we just have a basic sine graph and we have some definite integrals that we need to solve for. Okay, so we are given this piece of information right here. The integral from 0 to pi of sine of x dx is 2. So that's this shaded area right here. Okay, and I know that equals 2. Let's see if I can write in a bright color. Good, I can. So that thing equals 2, which means it wants us to use the symmetry of the graph. So if this is a perfectly symmetrical graph, I can say that this one is -2. And if I were to keep drawing my curve, so keep going, because it goes on forever, I would say, okay, we have another -2 right here, and I have a +2. Okay, those are the definite integrals. And I'll add some labels to kind of help me figure this out. So I know this is pi, this is 2 pi, -pi, -2 pi. And I'll fill in more as we need. Okay, so from pi to 2 pi, here's this definite integral from pi to 2 pi. We already found that. That's equal to -2. Got it. Then this integral from 0 to 2 pi. 0 to 2 pi. The 2 and the -2 we have to kind of add together. So that's 2 plus -2. That equals 0. They cancel each other out. Pretty cool. So that definite integral is just 0. Alright, then I see I have pi to, I'm going in reverse to pi over 2. Okay. I don't like when they go in reverse, so I'm gonna rewrite this as pi over 2 to pi. And I'm gonna say, let's make it negative since I switched the directions. So for me personally, I like going from left to right. It's easier for my brain to think about. So I'm gonna rewrite it going from left to right, and I'll just put this negative sign in the front. So pi over 2 to pi is half. You see, it's half of this. So if the whole thing is 2, half of it is just going to be 1. So this is -1. Okay, let's keep going. Here, we're going to use one of our properties. So I see I'm adding a number. So I can split this up into 2 integrals. This one, I know it's just 2. We've been talking about that. And this one, I will use my 2, my constant, times b minus a. So this ends up being 2 pi plus 2. Okay. At this point, I want you to try this one on your own. So try it on your own before me. After you try it on your own, so I should see work when I check your notes, you should get 4. So show me the work that you would take to get 4 right there. Okay. F is a little bit different, so I'm going to do F for you, and then I'm going to have you try G on your own, so pay careful attention. In both of these, I have something other than just X in there, so this is the case where I'm going to make a substitution. So I'm going to say, let's let theta equal x minus 2. So I'm just going to replace what's in there with theta. So that means I have to change what's in here to be theta. Now I have d theta instead of dx. But I also have to change these. So these bounds are in terms of x. So here I have x equals 2 and x equals pi plus 2. So now in terms of theta, it's going to be what I had before, so 2 minus 2. And then what I had before was pi plus 2. Oops, so it equals pi plus 2, and then I have to subtract 2 from it. So the bounds that I end up getting go from 0 to pi of sine of theta d theta. This should look familiar. It's the same thing that we were given in the very beginning. It's the same as this. It just has theta instead of x. But that doesn't matter. It's the same thing. This is equal to 2. Very cool. This one I want you to try on your own. So you're going to start off with some sort of substitution for theta, and then you'll switch these x values right there. So give it a try. In the end, I should see your work. In the end, you will get 2 again. Hee hee. It's fun. It's a fun trick. All right. Just a couple more. So the integral from negative pi to pi. Come on, you all can do this one. You should say it out loud. From negative pi to pi, the integral under sine, those areas are going to cancel out, and I get a big fat 0. Okay, I hope you got that before I got there. These two, they make us think about cosine. Oh my gosh. So let's do a quick sketch of cosine. It's very similar to sine, except it starts up, goes down, and then comes back up. So here we have pi, and there's pi, or 2 pi. Okay? So this first integral is just from 0 to pi. Hopefully you can see I have this positive area, and then I have this little negative definite integral, but they end up canceling each other out, and so we get 0. And then from 0 to 2 pi, let's keep color coding, I have more negative area, and then I have more positive definite integral. The negative and the positive, similar to sine, this is negative 2, this is 1, this is 1. So this ends up canceling each other out. So I have 1 minus 2 plus 1 is also 0. Cool. So this is all the final examples that we have here of how to use all the properties of definite integrals.